Now, in the previous video, Joe explained how natural philosophers came to understand the law of inertia, that an object will continue moving at a constant speed and direction unless it's acted on by forces. Now, there's a lot to pick apart from that statement. What is a force, first of all? How can we quantitatively describe the motion of an object? And how is that motion going to change when the object is acted on by a force? So we're going to start by showing how the motion of a large complex object can be broken down into simpler parts. I want you to think about throwing a water balloon up into the air. The balloon goes up and down, and it probably spins around and it changes its shape a little. Now, these are the three types of motion that can occur in any situation, from an explosion to a flower opening to a satellite traveling through the solar system. To completely describe the motion of the water balloon, we should specify exactly how each point of the balloon moves through space in time. For example, if we choose the knot of the balloon, it's going to follow some curly path that's going to be really difficult to write down an equation for. But it turns out that there is a special point associated with every object that moves along a much simpler path than any other part of the object, and this point is called the center of mass. It is much simpler to describe how this center of mass moves through space. And then if we really need to, we can describe how the rest of the object moves relative to this center of mass. Now, since our water balloon changes its shape as it moves, this means a point like the knot is going to change its distance from the center of mass. Now, that is really very challenging to describe mathematically. So we're going to restrict our attention to objects that barely change their shape at all, and physicists call these rigid bodies. When a rigid body moves, all the points of the object stay at their original distance from the center of mass. So you can describe the motion of these other points on the rigid body as simply a rotation about the center of mass, and that's much more straightforward to write down mathematical expressions for. But in most situations, just knowing how that center of mass moves is enough. And what this means is that we just have to track how a single point moves in time. So we're going to quantitatively describe a single moving point, and this means we need to keep track of its location in both time and space. Now, as a word in English, time can mean a few different things. It can mean a point in time, such as what time is it? Or it can mean a duration, as in how much time does it take me to swim 50 meters? In physics, we write the symbol t to mean a point in time, and the symbol delta t to mean a duration. Now, this delta t is just a single symbol. It's not two different symbols multiplying together. It's just a single thing. And we calculate delta t as the end time point minus the beginning time point. Now, I hope you all realize that our position in time can only increase, and there is no way to go back in time unless you're traveling with Doctor Who. So delta t must always be positive. Now, we can do something similar for positions in space. We write x to mean a point in space, and delta x to mean the difference between 2 points in space. And this is going to need a little bit more explanation. The difference between 2 points in space has both a magnitude and a direction. Physical quantities that have both a size and a direction are represented by something called a vector. And the vector that describes a change in position is called displacement. We'll talk more about vectors and how to work with them in another lesson, but for now, just remember they have magnitude or size and direction. A key property of something that's moving is how fast it's going. This tells you how far the object moves in a fixed time interval. So in other words, speed is distance travelled divided by time taken. It's also important to know what direction things are moving. So in physics, we use the displacement instead of the distance and get a vector quantity called velocity. V equals delta x divided by delta t. And then speed is just the magnitude of this velocity vector. Finally, remember our law of inertia says that an object will maintain a constant velocity unless acted on by forces. So we need to be able to quantify changes in velocity. This is acceleration. A is delta v divided by delta t. Now, in everyday English, acceleration means getting faster, but in physics, acceleration is a vector quantity again. So an object that keeps a constant speed but changes its direction is accelerating, and an object that's slowing down has an acceleration whose direction is opposite to the direction of travel. So there you have all the key definitions for quantitatively describing the motion of objects through space.